Since the dawn of human civilization, we have been obsessed with mapping our place in the cosmos. From the ancient Babylonian astronomers recording the movements of Venus on clay tablets, to the Renaissance brilliance of Copernicus and Galileo, and all the way to the modern marvel of the James Webb Space Telescope, our underlying geometry of the universe has remained remarkably consistent. We have always thought in circles, and we have always thought in planes. When you close your eyes and picture the solar system, what do you see? You see a blazing sun at the center, surrounded by the neat concentric rings of the planets' orbits. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. They all sit on a flat, invisible table in space known as the ecliptic plane. This two-dimensional disk has been the absolute foundation of our cosmic awareness. Every map in every classroom, every digital model, and every trajectory calculated by space agencies is dominated by this flat perspective. Humanity has proudly declared itself a spacefaring species. We have hurled our robotic emissaries across billions of miles of the void. We have tasted the thin atmosphere of Mars. We have flown through the icy plumes erupting from Saturn's moon, Enceladus. We have captured the frozen nitrogen glaciers of Pluto, staring back at us from the absolute edge of the abyss. We look left, we look right, we look outward into the deep darkness. But there is a fatal flaw in our astronomical arrogance. There is a blind spot so massive, so fundamentally ignored, that it calls into question everything we think we know about our immediate cosmic neighborhood. For all our technological might, we almost never look straight up. Directly above the North Pole of our Sun, and directly below its South Pole, lies a vast, three-dimensional wilderness that remains almost completely uncharted. It is a region of space that should, logically, be right next door. And yet, it represents the single most difficult frontier in astrodynamics. It is the ultimate locked door. Tonight, we are going to abandon the safety of the planetary disk. We are going to explore the terrifying physics that prevent us from traveling vertically. We will uncover the dark, unseen forces that scientists know are raging at the solar poles. And we will delve into the chilling, mathematically sound theories of what might be hiding up there in the dark. From rogue, extinction-bringing stars to the highly logical possibility of extraterrestrial surveillance. Welcome to the apex of the solar system. Welcome to the vertical void. To comprehend the sheer magnitude of this blind spot, we must first address a deceptive question. If space is a vacuum with no up and no down, why can we not simply build a rocket, point it up, perpendicular to the Earth's orbit, and press launch? The answer lies in the cold, unforgiving prison of orbital mechanics. Right now, as you sit listening to this, you are not stationary. You are riding on the surface of a planetary spacecraft that is tearing through the vacuum of space at nearly 30 kilometers per second. That is roughly 67,000 miles per hour. Every mountain range, every ocean, every city, and every launch pad on Earth is permanently infected with this violent sideways momentum. When NASA or SpaceX ignites the engines of a massive launch vehicle, that rocket is not starting from zero. It is born with 67,000 miles per hour of sideways velocity already baked into its physics. For the vast majority of our history, this momentum has been an incredible gift. When we want to send a probe to Jupiter, we do not have to generate all the energy from scratch. We simply ride the Earth's momentum, slingshot out, add a few kilometers per second of thrust, and let gravity carry us across the flat plane of the solar system. But the moment you decide to rebel, the moment you decide you want to leave the disk and travel straight up, that gift becomes a physical nightmare. Imagine you are standing on a bullet train traveling at 200 miles per hour. If you want to jump off the train and land perfectly still on the platform, you cannot just step sideways. The forward momentum would violently throw you. To step off safely, you would need a jetpack strapped to your chest, firing with enough force to completely cancel out the 200 miles per hour of the train. Now, scale that up to the cosmos. To send a spacecraft straight up above the sun, you must first completely scrub away the Earth's 30 kilometers per second of sideways velocity. You must kill the orbital momentum. Only after you have burned a colossal amount of fuel to bring your sideways speed to absolute zero, can you begin to burn even more fuel to climb vertically? Engineers measure mission difficulty in something called delta V, the total change in velocity a spacecraft must generate. Escaping Earth's gravity and cruising to Mars requires roughly 4 kilometers per second of delta V. But to completely break the ecliptic plane and hover vertically over the sun, that requires a staggering, almost impossible 30 kilometers per second of delta V. Nearly 10 times the energy required to reach another planet. This is why, out of the thousands of satellites and deep space probes humanity has launched, almost none have ever dared to climb the vertical wall. We are trapped in a cosmic centrifuge. But if we cannot easily fly there, why can we not simply look there? We possess the Hubble Space Telescope. We possess the $10 billion James Webb Space Telescope. Surely, we can just point our lenses upward and see what is hiding directly above the star. Once again, the physical environment of the solar system blinds us. The flat disk where the planet's orbit is not clean space. It is an ancient, incredibly messy graveyard of cosmic debris. Over the last 4.5 billion years, asteroid collisions, crumbling comets, and the violent birth of the planets have left behind a thick, pervasive fog of microscopic dust. This is known as the zodiacal dust cloud. Because we live inside the disk, looking up means we have to look through millions of miles of this dust. But the dust itself is not the main problem. The sun is. The sun illuminates this dust, creating a blinding, scattered glare that drowns out the faint light of distant or dark objects. It is the astronomical equivalent of trying to look out of a dirty window into the pitch black of night, while someone is shining a massive floodlight directly at the glass from the outside. Furthermore, to look at the space directly above the sun's poles, telescopes have to point dangerously close to the sun itself. Instruments like Hubble and Webb are so incredibly sensitive that pointing them anywhere near the sun would instantly fry their billion-dollar optical sensors. They are strictly forbidden from looking inward. Therefore, the vertical space above the solar poles is cloaked by a perfect storm of natural camouflage. It is protected by an impenetrable wall of orbital momentum, obscured by the illuminated fog of the zodiacal cloud, and guarded by the blinding, destructive glare of our star. So what exactly is happening behind that veil? What do mainstream astrophysicists know they are missing? The answer begins with the weather. Not rain or snow, but space weather. The violent, highly radioactive storms that regularly lash across the solar system. We know that the sun's magnetic field is a chaotic, tangled web that undergoes a complete and terrifying reversal every 11 years. North becomes south, and south becomes north. During this process, the sun unleashes coronal mass ejections, massive explosions of plasma that can disrupt power grids on Earth, destroy satellites, and endanger astronauts. The key to understanding this entire 11-year cycle, the engine room of the sun's violent behavior, is located exclusively at its poles. Fast solar wind, traveling at over 800 kilometers per second, blasts out of massive dark regions called polar coronal holes. Yet because we are stuck on the equator of the solar system, we have never truly seen them. We are trying to understand a global weather system while only being allowed to look at the equator. In the entire history of spaceflight, only one probe managed to gather dedicated data from the polar regions. In 1990, the Ulysses spacecraft was launched. Because it could not carry enough fuel to fly straight up, it performed an act of orbital madness. It flew all the way out to Jupiter, diving into the terrifying radiation belts of the gas giant, using Jupiter's immense gravity to forcefully bend its trajectory out of the ecliptic plane. It then fell back toward the sun on a vertical orbit. Ulysses provided groundbreaking data about the solar wind, but there was a tragic, heartbreaking caveat. Built with 1980s technology, Ulysses possessed no cameras. It flew over the greatest uncharted territory in the solar system, and it was completely blind. We felt the wind, we measured the magnetism, but we never saw the source. Today, the European Space Agency's solar orbiter is painstakingly tilting its orbit using the gravity of Venus, hoping to get the first high-resolution glimpses of the poles in the coming years. But even then, it will only scratch the surface of the inner vertical region. What happens when we look further up, far beyond the magnetic storms of the sun, into the deep, freezing vertical abyss of the outer solar system? Here, the science bleeds into the realm of chilling, heavily debated hypotheses. Let us talk about the Oort Cloud. We often picture the solar system ending at the Kuiper Belt, the ring of icy debris where Pluto resides. But the true boundary of the sun's gravitational dominance is the Oort Cloud, a colossal, spherical shell of trillions of icy comets, extending perhaps a full light year in every direction. Because our telescopes are focused on the flat planetary disk, we only ever scan the equator of the Oort Cloud. In the apex, the regions directly above and below the solar poles, are vast, unmonitored oceans of deep space. And in those unmonitored oceans, monsters could be hiding. In 1984, paleontologist David Raup and Jack Sepkoski published a highly disturbing paper. They had analyzed the fossil record of Earth and discovered a pattern that defied explanation. Mass extinctions, events where vast percentages of life on Earth are violently wiped out, did not seem to happen randomly. They appeared to occur in a cycle, roughly every 26 to 27 million years. To explain this terrifying clockwork of death, astrophysicist Richard Muller proposed the Nemesis hypothesis. What if our sun is not an only child? Most stars in the Milky Way are part of binary systems, two stars orbiting each other. Muller hypothesized that our sun has a dark, distant companion, a red dwarf or a brown dwarf, a failed star that is too cold and too dim to emit visible light. Muller suggested that Nemesis is in a massive, highly elliptical, and completely vertical orbit. For millions of years, it lurks in the highest, most unobservable regions above the sun, completely hidden by the dust and the glare. We do not see it because we are not looking up. But every 27 million years, its vertical orbit brings it crashing down through the densely packed Oort Cloud. Its massive gravity scatters billions of comets, sending a lethal shower of icy shrapnel raining down onto the inner solar system. One of those comets, the theory goes, wiped out the dinosaurs. While the Nemesis theory has been heavily contested, and sky surveys like the WISE infrared telescope have ruled out a large, heat-emitting body in the immediate vicinity, the fundamental physics remain sound. A smaller, colder rogue planet, a super-Earth, or a dark, frozen Neptune, could absolutely exist in a high-inclination vertical orbit. We call this the search for Planet 9. If Planet 9 is not on the flat plane, if its orbit is highly tilted, it could be hanging directly above us right now, moving so incredibly slowly against the background stars that our software algorithms simply filter it out as background noise. It would be a ghost world, ruling the apex of the solar system in total darkness, but the mysteries of the vertical plane go beyond hidden planets. We must also consider the invisible architecture of the galaxy itself. Our solar system is not stationary. It is a ship sailing through the interstellar medium of the Milky Way, orbiting the galactic center at over 500,000 miles per hour. As we plow through the galaxy, we encounter interstellar gas, dust, and potentially dark matter. Dark matter is the invisible scaffold of the universe. It makes up 85% of all mass, yet it does not interact with light. We cannot see it, but we can feel its gravity holding galaxies together. Theoretical physicists suggest that dark matter does not just sit still. It flows in massive currents known as dark matter streams. Because of the specific angle at which our solar system is flying through the galaxy, and the shape of the sun's magnetic bubble, the heliosphere, some models suggest that the interstellar wind is not hitting us head-on. Instead, the magnetic poles of the sun might act like colossal funnels. While the equator of our solar system pushes material outward, the regions directly above the north and south poles might be the exact entry points for interstellar material to penetrate deep into our system. If you were to travel directly above the sun, you might find yourself in the eye of an invisible hurricane, a continuous, plunging waterfall of dark matter particles and ancient galactic radiation funneling straight down into the core of the solar system. It is a region where the physics of the Milky Way directly intersect with the physics of our star, completely hidden from human view, and yet there is one final hypothesis. A theory that moves away from natural phenomena and enters the realm of chilling, calculated logic. If we accept that the region directly above the sun is a physical fortress, guarded by the staggering energy requirements of vertical travel, cloaked by the zodiacal dust, and blinded by the glare of the star, we must look at this region not just as a scientific blind spot, but as a strategic asset. In the 1960s, radio astronomer Ronald Bracewell proposed an alternative to searching for alien radio signals. He suggested the Bracewell probe concept. If a highly advanced, ancient extraterrestrial civilization wanted to monitor the galaxy, they would not beam radio waves into the void and wait thousands of years for a reply. They would build autonomous, highly intelligent robotic sentinels. They would launch millions of these probes across the galaxy, parking one in every promising star system to quietly observe the biological and technological evolution of the local planets. If such an alien sentinel was sent to our solar system millions of years ago, its primary directive would be observation without interference. It would need to remain completely undetected by the inhabitants of Earth, even as our technology evolved from telescopes to radar, and eventually to spaceflight. If you were an alien engineer tasked with hiding a massive metallic observation post in the solar system, where's the absolute safest place to put it? You would not put it on the moon. We have walked there. You would not put it in orbit around Mars. We have a fleet of satellites mapping every inch of its surface. You would not hide it in the asteroid belt, as our deep space probes routinely navigate through it. You would park it exactly in the one place humanity's physics prevents them from going, and humanity's optics prevents them from seeing. You would place it directly above the sun's north pole. From a stationary vertical vantage point high above the ecliptic plane, a Bracewell probe would possess a godlike perspective. It would look down upon the flat disk of the solar system like a mechanic looking at the open gears of a clock. It would have a direct, unobstructed line of sight to Earth 24 hours a day, 365 days a year. It could intercept every radio broadcast, every television signal, every military radar pulse, and every internet transmission leaking from our atmosphere, and it would be perfectly, entirely invisible to us. Any astronomer on Earth attempting to look at the probe would be pointing their telescope directly into the obliterating light of the sun. Any radar ping we send out would be drowned in the immense radio noise generated by the solar corona. The probe would use the sun itself as the ultimate cloaking device. It is a basic rule of aerial combat. If you want to attack or observe your enemy without being seen, you dive at them out of the sun. The glare is your shield. Is there an ancient silent machine hanging high above the ecliptic, powered by the unending light of our star, quietly cataloging our history and beaming the data back into the deep galaxy? Without a spacecraft capable of breaking the vertical plane and looking back down, it is a chillingly logical theory that can be neither proven nor mathematically dismissed. The vertical void above our sun is not just an empty patch of space. It is the final frontier of our local universe. It is a locked vault containing the secrets of stellar weather that could one day dictate the survival of our electrical civilization. It is the hiding place of pristine comets and potentially rogue, dark planets that have been silently orbiting us since the genesis of the solar system. And it is the most logically sound hiding spot for anyone or anything that wishes to watch humanity in secret. For decades, we have proudly explored the ground floor of our cosmic house, entirely ignoring the attic. But the chains of the ecliptic plane will not hold us forever. Astrodynamicists are currently developing mission architectures designed to finally conquer the vertical axis. Some propose deploying massive solar sails, mirrors thousands of square meters wide, that require no rocket fuel. They would use the physical pressure of sunlight itself to slowly, agonizingly push a spacecraft upward over the course of a decade, spiraling out of the flat disk. Others propose a far more violent solution, the solar Oberth maneuver. A multi-billion-dollar probe would be intentionally dropped toward the sun, plunging into the fiery corona. At its closest, most terrifying approach, traveling at hundreds of miles per second, it would ignite its engines. The staggering gravitational slingshot effect would violently snap the spacecraft out of the planetary plane, shooting it straight up into the unknown. Sooner or later, human engineering will catch up to human curiosity. We will breach the vertical wall. We will rise above the dust, the glare, and the gravity. A camera built by human hands will finally turn downward and capture the very first image of the solar system as it truly is, a fragile disk spinning in the dark. And when that day comes, when we finally illuminate the apex of our world, we will have to hold our breath, because we might finally see what the sun has been hiding. We might find the source of the dark matter storms. We might find a frozen dark planet that time forgot. Or we might find that something has been looking back at us all along.